So, uh, so first thing first today would be again like our Scrum meeting kind of update from everyone who is joining the meeting, and then after that I will go over briefly about Chrome debugging, and then brother Ahmed will cover the intro to MongoDB. Brother, like I said earlier, brother Ahmed works at Apple, and he has worked with MongoDB, and he will give us an intro about what MongoDB is, and what are the different kinds of databases out there, and why we are using. I don't think he will answer why we are using MongoDB, but he will give us the intro between what is the regular conventional database versus the NoSQL or a Mongo database. So, so first thing, I would like to get an update from everyone, where you guys are, what you guys did last week, and then again, if you guys want to change something, want have feedback about our process, feel free to let us know. And I'll get started with Hamza. Hamza, go ahead. You want to show what you have been doing, and how the progress is, and is there anything that you need from us which we are not providing you?
Yeah, let me go ahead and share my screen. Cool. I don't have it running real quick, so I haven't made much progress since the last time we talked, but this week I was basically working more on getting like the front end stuff working.
Mm-hmm.
So all right. So this week I added some of this filter. None of this is operational yet, so it's not I can't search up names and the table won't like sort itself yet. That's something I'm planning on working on soon. Majority of my time was spent on this page, adding this tab and getting the tab functionality to work. I really only added this part here. I'm also playing around with the disability feature, so disabling and doing that. Yeah, and enabling it, and it'll be through the button that it'll work, but that's not functional yet either. And yeah, then the other problem that we talked about before already is the getting the values right. I haven't gotten to doing it yet, but I was planning on working more on it tomorrow. So that's pretty much it on the update for me. I'm thinking one thing, if we can, or if everybody is okay with it, maybe you could start meeting maybe twice a week instead, because we're in August already.
Okay.
And so I know most people are going to be starting school sometime this month or sometime next month, and it would be helpful if we could meet more times so we could potentially get this thing going faster and get it done before school starts.
We can look at that. And what about the time? Is this time not work for most people? Because I saw 2 or 3 people saying today that this time today I will be late because I will be off later from work. So is this not the time which suits everyone?
I think it suits the majority. I mean, I don't want to speak for everybody else, but I think the people that missed it may have just had some issues or something going on for today. But usually 9 p.m. I mean, at least speaking for myself, usually works.
Okay. Anyone want to speak about it should speak openly. That's if you guys tell us, that is actually better. That means you are giving it importance because you want to join the meeting, but you are late because you have other appointments. So if we can accommodate you, that would be beneficial for both of us, for us as well as for you. So yeah, so if anyone is thinking that we should change the time or a day, I mean, again, we will also talk about the 2 days, and then the second day we would like to know what should be the day. We need to get to that. We can bring this up in the end maybe. So next is Hamza. After you, there's Subhan. Subhan, what have you been doing?
So I worked on the jesting, so like just testing out a program using this jest which is a library from JavaScript.
Okay.
that is used just to test us specific functions you just want to test from the program. So for example, we're gonna implement that for like, for example, I'm in the payment with Wahaj and Rafe, and if we want to test out something with the jest method, we'll use that. If you want to like edit our code, if one of us want to edit our code just to make sure that part just functions correctly.
Okay, that's fair. But do you have anything to show us?
I don't have I don't think I saved the jest thing, but Rafe, I'm gonna go talk with Rafe tomorrow. Me and Rafe, he told me to
Okay.
Zoom meeting tomorrow to work on the tech.
Okay, so after we're done with the update, we will go through the stories, and then we would like the story owners for everything. I want to make sure that we have the owners and all the stories are assigned, hopefully today. Okay, so who's next? Bahaj, how about you?
Yeah, I did a little work on the payment page.
Okay.
So I was following the Confluence doc that we have. So if I can show that right here, the design we had, I think Rafa showed this 2 meetings ago. It's just like first column payment option, what you want to do, Sodaka donation, then the method, and then the information at the end. So basically I just did that with this. It's not clean. I needed to work on that, but I was thinking I put the options here, and then on the bottom I put payment history, maybe on the same page.
Okay.
Instead of putting on my account, maybe on the payment page, that'll be better. But that's just my thought.
Yeah, so I mean, if you guys get stuck on anything, I think reach out to any one of us, and we will see if we can help you guys out on ideas and how to address it. Sometimes we don't know the answer either, so but do try to reach us out so that we can help you guys move forward. Don't just wait for the meeting to let us know. So I think the WhatsApp group is still is not as active as I expect it to be. We should see more questions. Like yesterday, there was a question, or a couple of days ago. So we all jumped into the meeting, and then we'll try to help them out. I don't know how much we helped, but at least there was an activity going on. So keep that in mind. Okay.
All right.
Okay, Afif, how about you?
Yeah, so I'm opening up, I was using a different computer I've added basically a little table. I was working on a table so that we can like try to filter the information, because rather than printing to the PDF, I was thinking that we could put member list and use that to then generate a report, which is on an individual page. And then we can either print a PDF or export to CSV from that. So I was creating a table. I'm opening it up right now. So I'll tell you when I've opened it up, but, and then I can show it off sharing screen.
Okay. So you want to share it a little bit later? Is that what you're saying?
Yes,
okay,
of course.
Okay, sounds good. So you have any issues with the time, or you're good with this time?
Yeah, I'm good with this time.
Okay, perfect. Okay, so who's next? We have, is that it, right? Hello, Hisham.
Yeah, this week I was, I had an issue. Remember, I had an issue with my running the project even on my PC. So I couldn't start the project. So I did what I did. I just installed it on a container, and I'm currently using Docker to run it.
Okay.
And then I'm using volumes, Docker volumes, to map my folder on the local machine to the container. So when I update my local repo, it just updates the container.
Okay, perfect. You want to show us that at some point, or?
Yeah, I can. Towards the end, maybe I can.
Okay.
I can show it. Yes.
Okay.
Towards the end of the call, I can show.
And you can also show us how your Docker file looks like.
Yeah, sure.
Okay. Sounds good. Okay, so we have Urva as well. Urva, how is it going for you? Oh, I thought I saw her. Okay, she probably dropped off. Okay, anyways, so I also want to take a look at the stories in in our Jira, and then I want to see, let me share my screen now. So you guys are also pretty familiar with the Confluence as well, right? We have both the Jira as well as if you click on here on these hamburgers sign, and then you can click on the Confluence. It will show us all the Confluence pages. I have started creating few Confluence pages as well, but I would like you guys also to add more Confluence pages here. So for example, like a unit test framework, I have started adding some information how to test with the unit test. This is what I think Subhan was referring earlier. And then REST using the Express. So I started building this. I'll keep on adding more information here and more. So I would like you guys also to update those documents, whatever you are doing, whatever part of project you're doing. If you're doing, let's say the payment information, you should be updating the payment related Confluence pages. And we need to document everything which we are doing in this project. One other thing I would like to do today, maybe we'll do it towards the end of the meeting, that we assign out all the stories to everyone. And I think now I can we can switch focus towards the MongoDB. We can have Brother Ahmed go over the MongoDB. Do you guys understand what is MongoDB and why we are talking about it? So I can give you like a brief introduction of, so any software system which we build, it has generally a front end, a back end, right? Back end is generally two things, a database on the back end, and then there is a server which is running. So in our case, in our stack, our front end is React, our client, our server is Node.js, and our database is MongoDB. Why we need to have a database? Because we want to persist the data. When the data is entered into the system, we want to be able to save it and be able to retrieve it later when we need to use that data. So that's why we would need to have a database. So we picked the MongoDB for this project. So Brother Ahmed will go over the MongoDB. Go ahead, Brother Ahmed. It's all yours.
Assalamu alaikum for the introduction. So let me. All right, can you see my screen?
Yes, I do see your screen.
Great. All right, assalamu alaikum everybody. So just wanted to talk today briefly in a very, very informal manner about MongoDB. I didn't want to make it like a class. I also didn't want to make it like a project either. I just wanted to make it like a discussion. So feel free to have a lot of back and forth and ideas. Basically, what I wanted to introduce today is a new type of database that has been famous for a while now. It has its own advantages, and that's the one that happened to be the one that we're using, which is called the MongoDB. Although I'm going to be talking about MongoDB or in the light of MongoDB, another important aspect that I want to highlight is also the relationship between entries in the data. So think about it that you have a member. This member has some data entries related to them, as you all have seen and done before. They have like address, city, so on and so forth. And so those are things that are unique to that person, but there's also things that is like a child of that person, like related to that person. So like the person or the member and their dependents, whether that's the spouse or the children. So those we call, there is some sort of relationship there. So how should we implement it? What is the best way to do that? Also like the member and their activities in terms of logging in the website, logging off the website. So that's their activities. Or maybe the member and the payments. how much money they paid, across what time period, so on and so forth. And the application, once you have that stored in place and know how to recall it back and know how to relate everything to each other, that the possibilities are huge, right? Because then you can start pulling out who are the members that donate the most, for example. So who are the members that we should approach them in a time of hardship or in a time that we need a donation, or who's the more members who have been benefiting from some activities related to kids from age this to age that. So we should, when we have certain activities, we will send like a general email to the mass, but we will also send like a few specific emails to the members who have children from that age to that age. So there's a lot of things that you can imagine that you can do and automate once you have these relationships set in place and set right. And so what I wanted to show you today is just generally how we deal with MongoDB, and also like what kind of relationships that we can make between different records. And feel free to chime in anytime you have questions, okay? So there is now, or as of these days, the famous databases, there's like the SQL type of database and the NoSQL type of database. SQL type of database, that's a traditional database. That's one that has been there from like 1995 or so. And those are basically the databases that's like tables. And we access them using MySQL language or similar to MySQL language for that. It's you think about it as it's like a huge table being stored in a server somewhere. And every time you want to query or you have a question, you go to that table and you filter out that table based on this. Think about it as a huge Excel sheet that you have in your computer, but it's stored somewhere on a server. And that server is fast and big, so it can handle a lot of data. It also has some redundancy, so it can handle any failures and retrieve data in case any failures happen. So think about it as a big Excel sheet, but it has its own language query where you can say, I would like to select that column and that column and aggregate on them and bring me back the output. So it has a specific language. Since it has been there for a really long time, it became very mature. So the SQL language is very mature. It's like any other language that you can think of in terms of programming, like Python or Java or so on. It has now its own rules, its own syntax that has been set in place, and it's like engraved in stones that nobody changes this as we go. So it's the SQL itself is very mature, and the language to be used is very mature, and it has a lot of different functions since people have been using it over time. So it has a lot of different ready functions that you can just use and grab, and it will probably do exactly what you want. And definitely has a lot more support, again, since it has been used more or since a longer time, basically. On the other hand, the NoSQL databases, that's like a no structured database. It's a database that can store things and you really don't have to think about the structure. So in the SQL database, it's like a table. You really have to think about that structure of the table before putting the data in it. What columns is there? What entries are there? How I'm going to, for example, do the dependent and the member. So how many dependents should the member have? What if the member have more dependents than what we assigned? If we say we are going to assign 2 columns for dependents, what if they have 3 dependents? What if they have 4? How do we handle this? So you really have to think about all these things beforehand when you design your database. In a NoSQL database, you don't have that. So that's the advantage of a NoSQL database. It's very flexible, and it stores data in what we call unstructured documents or unstructured format. It's a format that can change from a person to a person. So for example, you can choose for a certain member to add dependents. For certain other members, you can choose to ignore completely that entry as if it doesn't exist. And you don't have to think about it beforehand. So let's say tomorrow you want to add something new. You want to add, let's say, for example, you want to add their previous home. So you can choose to add this for some members, and you choose to add and choose to ignore this for others. So basically, there is no like one rule governs you that you have to do it for everybody and every member that you have to do. So it's a lot more flexible than the SQL database. That's like the JSON format that I was telling you about. The way we store it is not like a table, but it's like a document. So for every document, you have what we call a key value pair. And if you're familiar with JSON format, that's exactly how it looks like. It's a key value pair where you have a key, like the artist name, for example. So that's the key. And then that's the value inside that key. So it's not a column. So for every entry, it would look something like this. It's not like a column, rows structure. It's more like a key value pair. So for each key, and then for those familiar with data structure too, it's like dictionaries, right? So for each key, you will have a value. So for example, this key is the artist's name, and now it has a value that's XYZ. This key has an address, and it has a value inside it that's like this big thing, right? But this big thing itself is another dictionary or another structure that goes, another data structure, another dictionary that's inside that it by itself has its own key value. So as you can see, it's a lot more flexible than just the big Excel sheet that we were talking about. So any format that you want to follow is acceptable, and you don't have to unify that format between different members. So one member can have the address looks like this, another member can have the address just like how we normally write it on your mail, 1110 blah 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 street, comma Tracy, comma California, comma Mountain House, comma California, then the zip code. So really no specific structure that you need to follow. It's you who designed this. It's you who you decide what kind of structure that needs to be followed. But if you don't want to endorse that rule, if you don't want to force that rule, then it doesn't have to be forced. Any questions so far?
Yeah, I expect you guys to ask questions. So Brother Ahmed, can we give a quick view of how that traditional table looks like versus if I have to store the same data in a regular table, how would it look like? Just maybe you can draw example here if you just draw a table. Yeah, exactly.
So if I were to do this in a table, I would have to do something like this, where I have to think about the structure beforehand. So what exactly do I want from a member? I want to know their name. I also want to know, for example, their address, but for address, I want it exactly as a component. So I have to have a street, then in city, then country, right? And then I'll start entering people. So that's the XYZ person. They live in a Polo Street. And then the city would be Bombay, and let's say country of India, right? And then for this next person, I have to have that information, right? So then I also have to have the artist name. So let's say ABC, and then the street. In this case, you have to sort of match the format. You can't now say, then I'll just say 1110 Michelle Avenue, right? That's where I live, so don't come visit me. But you can't basically say that, write the full address here and expect it to all behave the same, right? It's not. It might throw an error. For example, if you don't put the city name here, then when you ask the database to pull out the city and say, hey, what is the city of ABC? If you don't put anything here, although you put it there, but if you don't put it here, then it will be pulled as null. It will say, hey, that person doesn't have a city because he didn't enter one. So you're expected to have thought about it for every entry. Now think about the other example. If I want to even expand that table a little more, let's see if I can do that. I'm just going to make another table on the side. Can I actually add columns to the left? I think I should be able to. Yeah, insert column to the right. Now think about that. I want to add dependent, right? So I'm going to say dependent 1. Then you can start writing the name. Child 1. Then this guy has a child, ABC, so on and so forth. But what if this one of these person have 2 childs. How do I do this? Now you got to start thinking, oh, I forgot to add a second child. I have to go back and change my schema again. So now I have to go and add another column, right? So now I have to go to my schema and say, hey, schema, I'm sorry, I forgot to add another child. Now I have to go and add another schema. Okay, what happens if the person have 5 dependents, 7 dependents, 10 dependents, right? Then this doesn't scale well. And in this case, you can see the scalability is going to be rendered useless. And now what about the payments? How do I store the payments? Should I store it in a different database? Should they all have the same type of payments? How do we deal with this? Like, you have to think about the structure and the schema all beforehand. While what I have here, for example, in MongoDB, now we don't need that table. What I have here for MongoDB, come on, delete the table. Okay, delete the table. Well, what I have here, for example, then I can just say, it's as simple as I'm adding a new key and say dependence. Then I can add dependent 1, then name of that dependent, comma, dependent 2, name of that dependent, so on and so forth. And that's it. I am done. I added it for that record for this person, and I don't have to worry about it for any other person. So the extra information that I want to add, I can add specifically per record or per what we call a document. So for each record or each what's like a row in a SQL or in a table database, like in a MongoDB or a NoSQL, we call it a record or a document. So for each document, I can add as many details as I want, but I actually have to worry about how it affects the other people and how it would look like for them.
Could I ask a couple of questions?
Sure.
Okay, so first, so I see what you're saying about NoSQL databases. So if this is true, then what's the benefit of using a SQL database versus a NoSQL? Because if NoSQL is so easy to change and it allows you to have this so much I guess ability to change things without messing with other entries, like is there a certain reason that people use SQL instead?
That's a very, very good question. So I had this covered in the slide. So I wanted to talk first about the advantage of the NoSQL, basically the scalability and reliability, right?
Okay.
And then the no need for predefined schema, as we talked about. But here's the problem. The queries in MongoDB is a lot harder to do and to support than a SQL database. So that's the first advantage that you get in a SQL database. In a SQL or a table-like database, your data is well structured and the queries on it is simple, easy, and usually quicker. That's a huge advantage. And that comes to the fact that MySQL has been there for like a really, really long time. And as I said, it's now set on stone and great. So really well-defined, well-maintained, and well-structured data. And that's the first big advantage of a SQL database. A second advantage of a SQL database is that you can correlate between different databases easily. What do I mean by this? Let's say, for example, I have a database where I store the members' information, and then I have another database where I store the payment. I can write a very, very simple query that basically correlate between the two, or what we call in the world of data and databases, join between the two databases in a SQL, very easy. Where I can say basically, based on the member name, I would like you to join these tables together, and instead of them becoming two separate tables, they are now one bigger table. And if you dealt with Excel before, you might have done this already, where you have two different sheets and you wanted to end up with one sheet that's the join between the two. To do that in a MongoDB is quite painful, and actually takes a lot more longer in time than a SQL database. So in a nutshell, if your data is well-defined and your schema is well-defined and you're not expecting it to change, I would go the SQL route. But if my data has a lot of flexibility to it, has a lot of changes that can be added, has a lot of differences between the different records, then the NoSQL database route is the place to go.
So like quick question. So since you're saying like well-defined data is SQL is a better route,
Mhm.
so is it possible like prototyping when like you first start out having some data and you want to store it, you could go like a NoSQL route and everything will kind of be easier to change, and then eventually you would transition into a SQL database? Or is it like just two completely different use cases that don't really mix ever?
Theoretically, that's possible, and there is a lot of tools that exist as of today to do exactly what you said, where you have started with a NoSQL database, and once you've settled on, just convert it to a SQL database. But the key condition here is what you said. I am now stable, and I know for sure that I don't want any more types of data or any more different structures of data, and I know exactly my schema, how it looks like. Then I'm transferring this to a SQL database. And what I have seen happening in the industry is a sort of mix of both, where you still keep the NoSQL database for any changes. So for example, if you think about our MHMA page, it will store into the NoSQL database, but you can also make it so that maybe every week you get a dump of the NoSQL database into your SQL database. And then your query in the back end can happen in the SQL database. Does that make sense?
Kind of. So you said I'm sorry, I didn't get the last part quite. How do they exactly do that? You're saying they dump data from a NoSQL to a SQL database?
Yeah, so there's few tools that you can use that we say, here's my MongoDB or my NoSQL database, and I would like to convert it into a SQL database. And what this tool does, it goes over simply every key value pair and convert it into columns. And now it becomes like a table. And then it gets dumped into a SQL database.
I see. And the benefit of this is you're still allowed to kind of make changes since it's a, okay, but it deals with all like the exceptions. For example, if a certain extra thing is added into like your NoSQL database, and then it's not really a column, it'll create a new column. And
yeah, so basically from here you have two directions to go. You can simply say, I'm going to cancel the MongoDB. Now I know that I'm stable, and now I'm going to just change everything to write into the SQL. Now that I know that the SQL is good and well established, and that's what I'm going to use, then I'm just going to write into the SQL straight.
okay.
Or the other direction, which is what I've seen happening more in the industry, is you keep the MongoDB in case you wanted any changes. You still have the flexibility, you still have everything, and you just do that conversion on a periodic pace. Say every week, I'm just going to convert the MongoDB back into my SQL, or add the new records that I added into my
I see.
my SQL.
Okay, so you have the ability to make like quick changes, but at the same time, when you want to query your database, you can query easier.
Exactly. So now you have both benefits of both worlds. You have the NoSQL database where you can store everything in a flexible manner, and you have the SQL database where you can query and do nice applications, dashboards, and computations on them.
I see. Also, I have another question. You said that in NoSQL or MongoDB, the querying is harder. Could you kind of explain what you mean by that? Like in how harder, and like in how, like what do you mean by?
So I think probably Brother Ahmed will be covering this. I think some of
okay.
Let him cover. Yes, your questions are good. They all make sense, but I think let him cover the things which he has to, and then we.
Oh, okay, no problem. Sorry, I didn't know you were going to cover that.
So just the quick answer for what you're saying, harder is in terms of its two things. One, it's not well established as a SQL, because basically, like, you can think about Mongo as like a company that is doing this, or a community that's doing this, and it's not very mature yet. They haven't reached to the maturity that SQL at. So think about it as what? For example, think about it as Python language and R, for example, right? Actually, that's a bad example. Python and R are both will support it. Think about it as Python and a new programming language that just came up. You're gonna see that Python have a lot more support because it has been there for a while and it's open source and people contributing to it. But the other new language is still in development. So until it proves itself, not a lot of people are contributing to it yet. And so you don't have a lot of ready functions that helps you do your job quickly. So if you think about it in terms of programming, you need to write your own function for everything you do in the new language. While in Python, you can just call a library and the thing that you want to do is probably in there. Does that make sense?
Yeah, I got it. Thank you so much.
That's one part of it. And then the second part of it is the support. As I said, in a MongoDB, in a SQL database, it's very easy to join two tables together. In a MongoDB, that's not an easy thing to do. So a query that does that is going to be very hectic to write. So that's what I mean by a harder query. So how is the structure then of the MongoDB works? The structure is basically inside, you have what we call a MongoDB server. Inside MongoDB server, you have what we call databases, okay? And for each database, you can give different permissions. For example, think about MHMA. When I might have two databases, one that handles the members and their information, and the other that handles the payments, okay? For the one that handles the members, I am not going to give access to the finance team, but I'm going to give access to the activities team because those are the people who needs to know about our members. For the payments database, I need to give access to the finance team, but not give access to the activity teams because activity team doesn't deal with finances, but the treasurers and the finance team, those do deal with payments. So I'm going to give access to the finance team for the payment database. So each database, you can assign basically its own permissions and its own users to work on. And if, of course, you can have multiple users who are common between both. So you can have users who can access both databases at the same time. There's no problem with that. But basically you assign privilege of users per database. And then inside each database, there is what we call collection, okay? A collection is actually where you store your data. And I'm gonna show you an example of how that looks like in our own MHMA database. So let me share the other thing here. If you wanna sort of do this exercise with me, so I sent earlier a link on the WhatsApp group to download this Robo 3T. There is multiple tools that you can use to have a GUI access, a graphical user interface access to your database. One of them, and it's like the most mature out of them, is what we call Robo, or a 3T. That's the company called 3T, and they have two applications. One is called Robo, and the other is called Studio. Robo is free. Studio you have to pay for it. It has some extra features. So Robo is very sufficient to what we're going to do here today. So if you have access to it, then you can simply see everything that I'm seeing here on your own computer or your own database. So, Brother Naeem, is it okay if I send this SRV over the WhatsApp group? Or
yes, yes, absolutely. Yeah.
So can you go ahead and send it? I don't have access to my WhatsApp right now.
Okay. Yeah, I'll do that.
Actually,
so,
I'll chat. Hold on.
So do you want them to connect to the using Robo, because they might not have installed this tool yet? So
I sent earlier on the WhatsApp group to install it. So whoever installed it can do it with me. If you haven't, then you can do it later.
Okay. Yeah, I'll share the string just a minute.
I have it. Don't worry. I have it. I'll share it on the
Chat. Okay.
I'll share it in the chat. So I shared like a big string on the chat. If you have the tool and you sort of want to follow up what I do. So once you open the tool, you can see there is like 2 computers over here. This is where you can create a connection. So if you click here, then say create, you should end up with a screen that looks like mine here, where it says connection settings. Can you see it? Okay, good. And then if you go at the very bottom, so there's multiple ways where you can put the username and password and the address. But if you go at the bottom, we already done that for you, where we have what we call SRV link. So if you just take that string that I put in the chat, copy paste it here at the very bottom and say from SRV, it already fills that up for you. So you don't have to worry about what is the username and password authentication. So that string here have it all, basically. It's like our own QR code for Mongo, if you want to think about it this way. And just if you want to make sure that it works, then say test. If it works correctly, then you'll see two green checks here. You can close it, then say save. Once you save it, you should have it like how I have it here, and you can say connect. And once you connect, you'll have those things on the left side here. And here's the example of the multiple databases that I was telling you about. In our MHMA database, we have 2 databases that is there. The first is the MHMA database. And if you click on it, you can see collections, functions, users. If you go to collections, you can see inside this database. So who are the authorized users? Who are the members? The sessions, the users. So each one of these we call a collection. So MHMA, that's a big database, and inside it, it has 4 collections. Think about 4 collections as 4 different Excel sheets. And think about database as different Excel file. So each database is an Excel file, and each collection inside the database is like an Excel sheet. If you click on any of these database, it will give you like the, let's say members, for example. You can see that there is 5 records in here. Record number 1, record number 2, record number 3, right? So for each of them, they have their own entries. So this is the first name, person, last name, so on and so forth for all the 6 records. You can choose to view it like this, a tree style. So that we call that like a tree style, because you have to unfold the tree to be able to see what's inside. You can also see it as a table style by clicking here. Or you can see it as a JSON document style. And basically that's document 1, then that's document 2, and then that's document 3. And then you notice for every document or for every member that you see here, for every one of these documents, you can see that they are not they're not consistent, right? So this person has a first name, last name, house number, street, town, created at, right? City, and then the underscore V. But this next person has a lot more information. They have country, state, gender, card expiration, card number, blah, blah, blah. So you can see that I don't have to have the same information for every person.
If you're gonna cover this, it's fine. But are you gonna cover like when querying like a NoSQL, like when querying and like something doesn't exist?
Yeah, we'll give you examples of this.
Okay, all right, okay.
Okay. So that's basically the structure of the MongoDB. For us today, I created another database, the learning database. So that's the database I created. It has a books, and then it has another database called the child. Okay. In books, I sort of like have a bad naming convention. In books, I'm actually storing the author's name. In child, I'm actually storing the book's name. So that's a bad naming convention. So don't do like me. But I was just in a hurry, so I guess I bad named it. So this is the example that I'm going to be working on for today. I wonder if you can still see my PowerPoint.
Are you sharing right now?
I'm sharing it right now.
No, we are not seeing it.
So let me go back to it. All right, so now I can share both.
Yeah, now we see here. It's on the behind. Yeah.
So as we established already, each record is called a document. And once you are in the database, you basically can insert the document in the collection that you would like to insert it on. So for example, when I went here and I clicked on MHMA, when I went here and clicked on MHMA, I am currently inside MHMA, sorry. When I clicked on learning and I asked to open the books_example1 collection, that means I'm currently inside the learning database. So you can see this one. You can see I'm right here. I am actually inside the learning database. So to make it clean, I can open it all from the beginning, so we don't have a mix-up. So like right here, I'm learning, then I go inside here, and once I click, I'm actually now inside the learning database. And specifically, I'm inside the books example1 collection. You can see here I added about 6 different records for us to check it out. So if you want to look at them as a table, you can just say view results in a table. And you can see the names of the people that I added. I added one person called 1-to-1, another person called 1-to-1 example2, example3, then one-to-many UVW. So those are the authors of my books. So I added like 6 authors.
I have a question. So are you able to edit anything through the actual database, or does everything have to be through the actual code or the website to edit anything on
You mean
database?
through that GUI?
Yeah, because I went to the JSON format and I was just kind of like messing around to see if I could type anything on it, and it doesn't let me. So I'm assuming you can't add like a whole new member.
Yeah. This tool actually allows you to do editing for existing records or even new records by basically going here and adding extra people. So you can actually, let's see. If you go into that tree here, right, you can simply just go here and say edit document, and then you can change that person name. So you can say, for example, I want to be UVW2, then save, then we'll edit that.
I see. Okay, thank you.
So this tool allows you to do this. Other tools, some of them don't, but basically what it does here in a GUI, it actually goes and write a code in the background for it. So to insert a document, all you need to do is basically say, when you are in the database that you want, say the collection name. So now I want to add it in example1, then say .insert. So .insert is the function to add records. You can add one record at a time, or you can also add multiple records at a time. So for example, I'm gonna add this person. I'm gonna go here. Notice that what I currently have is artist name, address. And inside address, I have a bunch of stuff, but that's basically the only thing that I have. So let's go and add it together. So I'm gonna go here. I can delete this, and then I can copy paste what I have in the PowerPoint. And I'm gonna call this person XYZ2.
A quick question. Did you do anything to get the editor to pop up at the top, or it was just like that?
So let's start from the beginning. Here I have nothing.
Mm-hmm.
Then I can just do this. Once you open it, it already has a query that says find. Find basically without anything inside. That basically is a query that basically says display all the records for me.
Okay, yeah, I'm on Windows. The UI is a little different.
Oh, really?
Yeah, it's fine. I think I
So
found
one
it.
thing you can do, you can also go on the database here,
Mhm.
right click, and then say open shell.
Oh, okay. Yeah, I can see that.
And that should give you the editor also like mine.
Yeah, I got it. Thank you.
So again, I'm going to insert this XYZ2 person. And once I write, so insert is basically you open parentheses, you close parentheses, and then you write your JSON style, which is the key value pair inside. After you write your query, you can just go and run it from here, this play button up here. You can basically click it. And then it says I inserted word record. And it took me 109 milliseconds to insert that record. If I want to go see that record, I'm just going to click again on books example 1 collection. That's where I put it. And you can see a 7th record has been added. That's the very one here. The bottom, you can see artist name is XYZ2, and then that's the address fields of that person. And notice that there is automatically something that got added by Mongo itself. Automatically it added a record called _ID, and it has an ID object inside it. I didn't add this. If you look at my query, I didn't have any ID key here. So when I don't have any ID key, what Mongo does is it adds ID from its side, and that's ID for a document. Basically, that's a unique ID that cannot be repeated across documents. That comes very handy later when you want to correlate between databases. So for example, you can think that if I don't want MongoDB to add ID from its own, I can, for example, use the person's driver license or state ID as the ID for the MongoDB, and that becomes a unique entry for the person. So ID is something unique. Either you add it, but if you don't add it, MongoDB will add it for you. And that becomes very useful later because you can index on this ID, so the answer comes back quickly to you when you index things. We're going to talk about indexing later, probably not today. And also you can correlate between things on different IDs. So for example, you can say for the person that have ID F179 blah 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 California license, what was their payments? So I go look up the payment database using that ID, and now I can identify that. So I use their ID across different databases, and I can now correlate between them. Does that make sense? Any questions?
So for everyone, is it okay if we can extend it a little bit? Is anyone has any other appointments after this? Because it looks like we haven't gone even halfway. So it will take a little bit more time for Brother Ahmed to finish us.
It's my fault. I talk too much.
No, it's not your fault. I think it's a very good discussion going on. So hopefully everyone is okay. And if someone wants to drop off, it's fine because we are recording it anyways. Yeah, keep going, brother.
Brother Ahmed, can I ask a quick question before you go on? So are documents kind of documents are kind of equivalent to like entries, right? Right, you said.
Correct.
So like in a SQL database, every entry in a table would be like a document in a NoSQL.
So every row would be translated into a document. Into
Okay.
MongoDB. That's how I would think about it.
Okay, all right, thank you.
And every column will be a key, and the value inside that column will be the value. That's how I conceptualize it as a table if I want to. Sometimes that helps. Alrighty, then let's see. So how do I retrieve a document? How do I get back to a document? If let's say I want to search somebody, then we have this function called find. So the function find, it's written as simply, you can simply say, I'm going to go back to my shell here. I can erase that since I don't need it. I basically say db dot the collection name, in this case, books underscore example one, then dot find, open parentheses, close parentheses, then open curly brackets, close curly brackets. If I just don't put anything inside this curly brackets, that means I want all the documents. So that's like a query that says find them all. So it will give me all the documents that I want. But for example, if I want to focus on specific things, so for example, I want to find the artist name. So you give the key that you want to find. So I want to search in all the artist names for a person that their name is 121 underscore example one. So you basically give the name of the key that you want to search in, and then the value that you want to be searched. And between them is a dot. So it's a key value pair. So everything in the non-SQL is a key value pair. Everything you want to do is you do it in terms of a key value pair. Now that I run my query, it will say, hey, there is nobody with that name, which is weird because I know that I have one person with that name. You can see I already made a typo. I said 1 to none. Actually, the person name is 121, not 1 to none. So if I run it again, it will give me the document, only the document that has a person name 121 underscore example one. Then I can see where they live, what street they are, what city they're in, what country, so on and so forth. Let's do a little more complex query. So I want to search for people who live in the country of India. But country, as you see, it's inside, it's a key that's inside another key called address. So it's a key inside a key. How do I reach that? You basically say address dot country. So anytime you want to go inside another place, you say dot. So address is a general one, and inside that there is a country, so you say address dot country. And then I want to say here India. So basically that's a query, says display for me everybody, or return back to me everybody lives in India or has a country India. Again, to run it, you can basically do command enter or just go in here and the play. And you can see that I have 3 people living in India. That's the first person, the 1-to-1 person, example one. I have another person called one-to-one example 2. They also live in India. And I have a third person called XYZ2, and they also live in India. And now you can generalize this saying that I want dependent.age greater than 10. You can write such a query where you can say, I want dependent.age greater than 10, and that will return back to you the members who have children with age above 10.
What if you want to everybody who's not living in India? You can put an exclamation mark before the parenthesis.
Yeah, so there is basically a way to do this, and for that we have I provided a web page here.
Oh, okay.
Where basically if you go in here, it will tell you all the different styles of finding. So how you can do less than, how you can do greater than, how you can say not, so on and so forth. And also, by the way, Mongo supports searching as a regex. So for those of you familiar with regex, you can say, for example, I want to find everybody whose name contains the letter D, or the set of letters D, C, E, whatever.
Yeah, I don't think many people will be familiar with the regular expression, but I think we will cover at some point when we'll cover some shell commands. Probably, I think regex is probably one of those things which are very useful on the Unix environment as well. Yeah. I mean, programming world certainly I agree, but yeah, we will probably cover that also at some point. Ahmed, if you can help out on that as well.
Definitely. So this link right I put right here has everything that you want to find about how to query. So like, how do you want to do not? How do you want to do greater than, less than? How do you do multiple entries or a list or an array inside, so on and so forth. Now for the important part for this specific project is the relationships. And I'm going to give examples here, and I'm hoping as I give the example, you start thinking, what is the best way then to do it in terms of our data for MHMA? How should it look like? Which one would be more suitable to what we have here in MHMA? So relationship, basically, that's when records have some relationships to each other. Usually the relationship that we're looking for is some sort of a parent-child. So like a tree, if you think about a tree, then you have a node, and then underneath it is a node that belongs to the node on top. So that's like the parent of the tree, and then you have the leaf or the child of the tree. So although MongoDB is not SQL, as I know, SQL grants you freedom, but they usually say it's not the best to represent that. But you still can do it. So it's not like you cannot do it. Yes, you still can do a parent-child relationships in Mongo. It's just not as easy or intuitive as you do it in a SQL database. So let's walk through some of them together. So if you think about parent-child relationships in general, which what applies to MHMA here, you can think about a parent will be a member and a child, for example. It can be the payments for the members. It can be the interest of the members in terms of like activities. Some is interested in religious activities, some interested in sports activities, some interested in school activities, right? So activities itself can also be a child for a member or for a parent. And then the dependents, that's another child. Address, that's another child, right? So anything that relates to the original member, that can definitely be a child. In terms of relationship, we have 3 types of relationships. We have one-to-one, where there is a unique mapping between each member and, for example, their state ID. So that's one-to-one. So each member have their own state ID, and that's the one-to-one mapping. Nobody else would have that same state ID. And then there is one-to-many, right? So one member can have multiple childs. For example, one member have multiple payments, or one member have multiple dependents. And then there is many-to-many, where one member can relate to multiple things, and those multiple things can relate back to multiple members. Let's take an example for the one-to-one. Here's the example we just did. I inserted this person earlier. And so if I start thinking about their address, there is some sort of like a one-to-one relationship in this case, right? Where each member have only one address. It's not like they have multiple address. No, each member, so that person XYZ have one address, has one street, they have one city, one state, one country, so on and so forth. And so to do the search, we just did that example. For example, if I want to find who are the members that live in India, then I can simply just say, go into the key that I'm interested in and find the value India inside that key. And that brings me back the results. One-to-many in this case is you can think of in terms of the examples that we have been working with, the books and the authors of the books. So I have this author of the book, their name is one-to-many _ example 2. You simply insert it the same way, right? DB dot the collection name that you want to insert it in, then dot insert, then you insert everything related to that person. You can see that their name is called one-to-many _ example 2. And now I am giving them books. So what books they authored? Those people that this person authored 2 books. One is called book 3, and the number of pages for that book is 80. And the other is called book 4, and the number of pages is 20. So in this case, that's a one-to-many example. One author with many books. I already inserted that earlier, so I can just show it to you how it looks like. So if I go here, that will be this person, I think, number 4. So you can see one-to-many, his name or their name is one-to-many _ example 1. In their books, they have 2 books. The first book, its title is book 1. Its number of pages is 50. And the second book, its title is book 2, and the number of pages is 100. Next person have the same things, also called one-to-many, but example 2. They also have 2 books, book 3, 80 pages, and book 4, 20 pages.
So Brother Ahmed, in the relational world, the traditional databases world, whenever there are relationships, generally we have to match the keys in that because they are separate tables. So you have to build those relationships. So one key difference here is that the one-to-many relationships does not require the children have 2 keys and have to match them with the parent because they are part of same document. Is that what?
So that is correct. So in MongoDB, you can actually choose to put the child. I was going to give both examples. You can choose to put the child in the same document, or you can put the child in a whole different document.
Okay.
Sorry, in a whole different collection.
Okay. And are there any benefits or drawbacks or anything for like, for example, in our use cases, which should we should go with?
I personally prefer it to be in the same document because it's a lot faster in querying.
Okay.
If you put it in different collection, you're simply doing a lookup.
I see.
And you know, a lookup function really takes a long time. And as you increase your number of members and your number of payments, your lookup is just going to be huge.
Right, right.
So I personally prefer doing it here. But then when you start thinking about it, it also sometimes doesn't make sense to put it in here. For example, it makes sense for a parent's dependent relationship to be all within the same place. But it doesn't make sense for a parent's payment relationship to be in the same document.
Yeah, yeah.
So then I would do the payments, for example, in a different one, while I keep the birth child here on the same document. That make sense?
Yep, yep, yep.
Very good question. Thank you very much. And I just want to go back to the PowerPoint just to see how I made books has 2 entries. Basically, the secret is this bracket right here. So if I put the bracket, then I can put multiple elements, and this becomes like an array or a vector. So that's the first element of the vector, and that's the second element of the vector. And as soon as it ends, I basically close that bracket. So that's how you can see, if you want to relate it to here, that's why you see element 0 and element 1 inside books. So that's the one after the brackets. That's the one after the comma before the end of bracket.
Quick question. If we query like books, then like if we want books with the title of something, would it go and then search all the books, even the ones inside the vectors?
Yeah.
Okay.
So I wanted to give you that example over here. It's exactly what you've been asking. So basically, I want to search all the books that are greater than or equal, that has pages greater than or equal to 70. Okay. So to do that, you simply just go again and do the find search. Right. And then in here, you say, I want to search, what I'm trying to search is books dot pages. Notice that I didn't say books 0 or books 1. So basically I'm searching all the books, all the entries inside books. And what I'm searching for is that I want them to be greater than or equal to 70. To do greater than or equal, you basically do another curly brackets. Then, as I said, everything here is going to be key value pair, right? So $GTE, just like how I have it here. So $GTE. That GTE means greater than or equal. LTE means less than or equal. So GTE, say 70. I'm basically looking for people who have books that have pages that has more than 70 pages. And if I'm done with that query, then I just say run it. You can see 2 people came back, because this person, their book number 2 has 100 page. So that's why this person came up in my search. And then this person, you can see they have their book number 1 had 80 pages. So that's why these 2 people came up in my search.
So the results you got back were 2 documents, right?
Yeah, 2
So-
documents that have 2 people with this criteria.
I see. But then you can't, for example, like both these people have more than 1 books, right? Or at least one of them has more than 1 book.
Mhm.
How can you tell? You'd have to go in and check because if you wanted to know like the exact book which has more than 80 pages, you'd have to go and manually check, or how'd you go and do that?
Is your question basically which book out of the multiple books?
Exactly, yeah.
Okay, very, very good question. So how do I only get the child that I'm interested in? In MongoDB, you can do the queries. So see, that's a query right here. And that's the same query down there. Same exact query from here all the way to the left. Right? From here all the way to the left, that's the same query as the top. But if I added to it this thing, this very little thing at the back, books $1, basically this addition that I can add to the query, I am basically specifying which elements that I need to be returned. So instead of returning everything, for example, I just want to return the books that actually have that. So to do this, I basically go and modify the query saying that I'm done with the query, but I want to return, as I said here, I want to return, oops. I want to return curly brackets, books, dot $. So that means I want to return all the entries inside the book. That's the page and the title, because I want to see both. And then column 1.
Yeah, but we need the user and the book, which is only greater than 70, basically. Like I want the user, of course, because I want to know the user. But if the user has 100 books, I just want to see the book which is greater than 70 pages based on the query. Because maybe I'm looking for the name of the book.
Okay.
So if I'm returning 100 books, I have to go through each one of them to find the book which is greater than 70. I think this is what Subhan was wanted.
Let me do that query.
Let's first address this one. Yeah. Go ahead, Brother Ahmad. Yeah, first address this one and then we can.
So books dot $1, that's basically, this one is like a true and false. So
Yeah.
like 1 and 0 basically specifies which elements do I want to return. So if I want to return the title only, I can say books dot title. If I want to return the pages only, then I can say books dot pages. If I say books dot $, that's basically returning everything inside the book. So when I do this, you can see 2 objects still showed up. That's the first book. And that's the second book. If I want to also see the artist name, then I can also do comma, artist name.
So this is what you meant, Brother Ahmad, earlier when you were talking about complexity, that these queries are not as simplified as we haven't talked about the relational database SQL language, but these are much more, look like more complicated than the SQL language, right?
Exactly this. And so you can think of the queries and SQL. It's as simple as going into your Excel sheet and just click there and say filter, and then just write the filter name and it does everything for you. It's very simple to do the filtering and the queries in SQL. Here's quite painful. You have to write all these things and which one to return, which one to not return, projection, aggregation, all this stuff. You have to really think about it.
Right, they are painful, but if you look at our JavaScript language, which we are using for this project, it uses all of it. So
Correct.
all these structures which we are making, they are being used. So the data is retrieved in the form of JSON anyways. So if data is stored as JSON, that's actually, we are in a perfect world. But yeah, I just wanted to add this.
Yeah, and usually writing those queries on different languages. So like Python has support for MongoDB, Java has support for MongoDB. I think Node JavaScript also have support for MongoDB. All these have actually their own libraries to deal with MongoDB, and it makes your life slightly easier than what you see right now. I just wanted to do like build the basics, and then when we go to the node.js and start writing the MongoDB queries there, you will appreciate that it makes your life slightly easier when you deal with them. But it still is not as easy as doing it in SQL, for sure.
So what you're writing right now, like what language would you classify this as?
That's a straight up raw MongoDB query.
Oh, this is just straight raw MongoDB query, just MongoDB's whatever they use to query.
Yeah, I'm basically talking to the MongoDB directly without any compiler in between us.
Okay, perfect. Okay, thank you. Makes sense.
And so you can see here, I got the book and I got the artist name as well.
Yeah, and it got the book, which is only the 100 greater than 70.
Yeah.
Yeah. That was my question. Thanks a lot.
You're welcome. And then to Brother Naeem's question, then he was asking earlier, you know, sometimes we do things on different collection or in different tables. Does it make sense to do this here? And yes, there are some times where you get to do this. And in this case, I have two different collection. You can see the one before last person that I added, this guy, number 6, I only added their artist name, just their artist name, and their artist name is UVW. And instead of adding their books, I just wanted to show you a different style. Instead of adding their books inside like how I did here, I actually made a different collection called a child. And the books are actually inside here. So in this one, it has the name, it has the pages, and then it has the author name of the book. So that's book number 1, authored by UVW. That's book number 2, authored by UVW. And that's book number 3, authored by someone else, not UVW, right? And so you can see that that's a different style from what we have done, in the other one. You can see here, I already added the books as part of the document. Here I'm adding the books as part of a different collection, a different table, basically. And it's a completely different style, which is fine, right? But you will see how the query is gonna get more complicated as I do this. You can think about it as I made this database for this person to contain their artist name, their the artist name, and then maybe their address information, but nothing about their books. Just their name and their address, for example, right? And then this one will contain, the child will contain the books. And now the question is, how do I link between the two of them based on the artist name? How do I say, for the artist name called UVW, bring me their information, bring me their books from the child version or from the books database? And you can see that the query is right here. See how complicated it got? It is no longer find, and it's no longer SQ'd as just one key value pair. It's a lot of things now. So here I say, using the author database, books example 1, I want you to look up, basically I use it to look in a different collection or a different table. So I want you to look up the child database. That's where the books names are. The local field is artist name. So I'm basically saying the local field is artist name. So I'm saying look based on the artist name. That's the key. That's the key for the name of the person in books example 1. In the child, that same key is actually called author name. So I'm saying match artist name to author name, match artist name in the author's database with author name in the child database, and return for me the books. But I only want you to do this for this person, the person that has name UVW. So now you can see how complicated the query started to get. So if I just take that query, copy, paste it in my Mongo. You see that I get UVW and their books, they have 2 books. They have ABC with 10 pages, author name is UVW. So you can see the artist name will match the author name. And then I have also DEF, right? That's the second book. It's called DEF. The pages in that book is 50 and the author name is UVW. So you also see that the author name will match the artist name. So artist name is from the first database, and author name is from the second database.
Is the local field and the foreign field is like the primary key and the foreign key in SQL?
Exactly that. That's the keys that you want to join at.
Oh, okay.
So local field is from the one that you are starting the query in, and foreign field is the one from, that's the child.
All right.
And since you asked that question, that means you know SQL. So you probably know how easy to do that query in SQL versus what we have done here.
Yeah, so in SQL it's just like you'd be a join and then
Exactly.
on books and then you just find the books, right?
Yeah, and
Actually,
we both
SQL
have
is much straightforward than
Yeah,
this.
yeah.
Yeah, so we could have a session on SQL also at some point, but we should have ideally first the SQL and then NoSQL, but that's fine, I think. So I think at some point we will cover SQL also. I think it's an important topic, and then we can have a good comparison.
So
Go ahead, Rafael.
could you go back to the result of the last query? Yeah. So the data of books 0 and then books 1, like name, pages, ID, author. This is coming from child, right?
That's this one and this one.
Exactly. So that data is coming from child, but then the one up, the author, that is coming from.
No, author name is still also coming from child, but artist name is coming from the local.
Okay, I see. So it's gonna go and find
That's
all
what
the authors. Okay, it's gonna find author UVW and then find its information in child.
correct.
Okay, so if we remove the artist name condition to be UVW
This will match on everything then.
on everything, so you'll find all the authors and all their books.
Yeah, so that's like saying for every member, bring me back their payments.
Exactly. Okay, I see.
So I'm sorry I've taken like extra half an hour for that, but as I told you, I talk too much. So sorry
Okay,
about.
I think that's good for as long as kids are not sleeping. I hopefully they are. I see Rafi quite active, but I expect the others to ask more questions as well.
Can you send this file into the WhatsApp group chat?
You mean the PowerPoint?
Yeah, the PowerPoint.
I think Brother Naeem, what do you think? We should use the conference, so we should update.
Yeah, I'll put this in the conference. Yes.
Oh.
Okay, perfect. Yeah, I was gonna say that too. I have one actually other question regarding just the NoSQL database structure. I noticed since every entry is like a document, could you have a duplicate document, essentially like a document which is the same data? So for example, like same author name, same number of books, and everything is the same. Could you have like a multiple entry?
Very good question. The answer is yes, as long as you don't put any of them as an ID. So if you don't use ID, so as you see here, none of the documents I used ID, so ID got assigned automatically by MongoDB. But if I start using ID, let's say for example, I'm using the author name as an ID, then MongoDB will flag and say, hey, I've seen this document before. But if you don't, then it will be fine. MongoDB will repeat it as many times as it takes and assign a different ID for each of them.
I see. So ID is basically like the primary key in SQL databases.
ID is like the index key, if you want.
Okay, I see. So ID is what differentiates all the entries.
Correct, and that has to be unique. And if I simply repeat it, then that would be a problem, right? Then,
I see. Yeah. And like you said, MongoDB gives you the option of not setting it, I guess, where it automatically sets it.
And then there is another option that MongoDB gives you that even if you don't set it, you can later on say, I would like you to use name as an ID. And then MongoDB will reset itself so that names are ID. But if any of them is repeated, then the validation will come back and say, hey, one of them is repeated, that I cannot do.
Okay, I see. So if you try setting the ID to like a different like name and there's duplicates and it won't let you do that.
It will come back with an error, tell you can't do that.
An error. Okay, makes sense. All right, thank you.
So Brother Ahmed, how many slides we have more? Or?
That's it, I'm done. I think
okay.
The last thing is like what's next, basically. Next, we can talk about indexing. So indexing later, we can talk about indexing. So indexing basically is how to make the queries faster. So that requires a little bit of thought. Indexing is basically like, think about Google Pages. When you search, it gets you back the results very quickly. Why do they do that? Because they have already done some keywords and they stored it aside. So that's how they get you the results quickly. They don't do the search on the spot. They store some fields or some indexing on the side to help get you the results quickly. So then we can talk about how to do indexing on Mongo. So for example, we can index on the people name or the people address or the village, because that's something we want to search quickly. And then we can also talk about queries using other language. So instead of dealing with the raw Mongo, how do we do this in JavaScript or in Python, right? And then what else? I'm open to anything else you guys think is interesting. So if you, I think after what we've done today, you need to give it some thought of how we can apply this on MHMA, what kind of schema, what kind of collections you want. And then from there, if you need any extra sessions on MongoDB or any extra help on queries on MongoDB, I'm more than happy to provide for that.
Yeah, I think, Brother Ahmed, that's a very good point you made in the end, that we should have a session for us to design our MHMA database. Maybe we do a session just talking about it, what is the right design and what are the benefits or drawbacks of going one way or the other, because we could go separate document or the same document. I think that would be important question. And then the relationships will be one to many or many to many. So how we do those. So I think that probably we can do maybe in one of the sessions. Do you have anything else or you're done?
That's it.
Okay. So I have still 2 topics to cover, and I don't think I want to cover now because it would be too long for everyone. Is it possible we can meet tomorrow? Does 9 p.m. tomorrow work for everyone, or it's not something, or any other time? Which what I want to cover is debugging on the Chrome. And we want to assign out those Jira stories which we have created. So these 2 things we want to do. So what is the time? Is 9 p.m. okay, or do you guys want to have a different time tomorrow, because Sunday is the last day of the weekend? Anyone? Okay, speak who cannot do it. Maybe that's a better way.
Oh, I can do it.
Okay. No, so say if you cannot do it. Okay, so I think as people are writing there, looks like everyone is okay. So let's do that tomorrow. Thank you so much for your time, and thank you, Brother Ahmed. It was a great session. I mean, we all learned a lot out of it, and I would advise everyone to maybe watch the recording again, because a lot of concepts there which are not easily understandable in the first shot. So taking a second look will always help. So I would advise everyone to watch the session, and then let's meet tomorrow again. Jazakallah khair. Assalamu alaikum.
Yeah. Jazakallah. Thank you so much, Brother Ahmed.